Start that record. Okay. What would you like to cover here?
I'm looking. A lot of this stuff I know how to do.
Okay.
But
how much trig have you had?
I had a little bit last year. And not too much. It's just the base. Like, I remember the whole Sokotoa and...
That's the most important part, is being able to know those. Also, do you know your reciprocal relations?
No, I do not.
Okay, let's go through those. Even though these three are equally as important as the other three, secant, cosecant, and cotangent, I tend to think of these as the three primary ones because these are the ones on your calculator. Unless you have a Inspire CX, and then you get all six of them on your calculator. But
I don't know. I have the Inspire you're allowed to use on the APT.
Okay.
Whichever that may be.
Well, to remember which of the other three go with these three, start with tangent. What's going to be the reciprocal of tangent from between cotangent, secant, and cosecant? Take a wild guess.
Secant? No.
Cotangent.
Oh.
Tangent, cotangent.
Okay.
What that leaves us is the other two, secant and cosecant. Well, secant goes with cosine, and cosecant goes with sine, which gives you exactly one co in each pair. There's a co there, there's the co there, and there's the co for the cosecant. So if you use that little technique to memorize it, as long as you know that the tangent is the reciprocal of cotangent, then you can always figure out what these two are. Which one belongs to sine and which one belongs to cosine. Now, given these three reciprocal relationships, well then it's also true that cosecant equals 1 over sine, and secant equals 1 over cosine, in other words, the reciprocal, 1 over tangent. So those 6 reciprocal relationships they want you to know. The other thing they want you to know for sure is the sine squared of x plus the cosine squared of x. Do you know what that's equal to?
No.
1. And that's all that I'm certain they want you to know. There's other stuff, but you'd probably get 3 out of the 4 trig questions correct by just knowing what's on this page.
Okay.
Okay? And rather than me trying to think of the other stuff, as we go through ACT practice tests, we'll come across trig problems. And we'll see what other kinds of trig they expect you to know. All right, what do you have in your review material here?
So I was looking at it, and it's the first part, and it's just geometry.
Okay.
It doesn't seem like, I mean, all of it I really know how to do. It's like trying.
Nothing on there at all?
Nothing that I don't know how to do. A lot of it's just like finding, a lot of it's just using Sokotoa to figure out.
Okay. So no matter what, okay, I don't know if they would have this on the test or not. They might. If I said the sine of theta equals root 3 over 2 in the first quadrant what is the tangent of theta equal to?
Wait. Okay. What's about a trig? All right.
Not sure that this is something you're going to find on the ACT, but you might. Basically, the solution here is draw a triangle, labeled theta. There's the right angle. And now since we know the sine of theta is square root of 3 over 2, well, that's opposite over hypotenuse. And now having 2 out of the 3 dimensions of the right triangle, I can use the Pythagorean theorem to come up with this side, which is 1. And now I can tell you not only the tangent of theta, but all of the other 5 trig functions. In other words, knowing just the sine of theta and which quadrant it's in, I can answer any other trig function. So what would the tan of theta be?
It would be, wait, so opposite over hypotenuse, right?
Opposite over adjacent.
Adjacent?
Sine is opposite over hypotenuse. In other words, if you look at your SOHCAHTOA,
Yeah.
that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I look at this triangle and I look at theta, the tangent of theta is the opposite root 3 over 1, or just root 3. Now, if you didn't know this technique, there's clearly, notice that I never did figure out what theta was. Didn't need to. I don't know what theta is. I don't care what it is. However, if I didn't know this technique and they said, well, what's the tangent of theta? Well, you could always use your calculator to come up with theta. What's theta equal to? How do you get it on your calculator?
I have no idea how to put theta on your calculator. Wait, there's a little
Well,
thing.
the way you get theta is by taking the inverse sine of that number. And I don't know if inverse trig functions are going to be on the ACT or not either. But basically, the sine of theta equals square root of 3 over 2 only if, let me write it like this, the inverse sine of square root of 3 over 2 equals theta. In other words, these two mean the same thing by definition. Here we're taking the sine of an angle and getting a number. Here we're taking the inverse sine of the number and coming up with the angle.
Okay.
And that's a good thing to know, is that when you take a trig function of something, you're taking a trig function of an angle. And when you take an inverse trig function, you're taking an inverse trig function of a number to get an angle. Well, that's all I can think of in terms of introducing you to trig, and I may have introduced you to more trig than you need. So it's better if you tell me what if you can find any difficult problems on that review material that you don't know, and if you can't, let's do ACT. We'll run into trig.
All right.
All right, well, we should do ACT, or you're looking?
I don't think I have it. Like, all of it looks like it's just finding angles, and I think I can do that.
Okay.
All right. Okay.
Let's see where we left off here. 39. Yeah, we're definitely going to get into trig. Because I don't think we've done much trig yet, have we? Have we run into very many trig questions?
I don't think so.
No, I don't think so either. which means we're going to run into them because there's 4 of them on there. Now, hold on. Open the previous page and get question 40. In case it's a trig. Ah, it is a trig. Glad I didn't skip it. Hold on. Almost did. So first of all, what's the tangent of alpha?
Okay. So the tangent would be the opposite, which is 4 over 3 for the.
And what is the cosine of beta?
So it would be 3 over 5.
Cosine?
No, so I have to write until I have, I don't know why. So it would be 4 over 5.
Good. So what is their product?
So 4 over 3 times
Don't.
4.
I wouldn't use your calculator because your calculator is going to give you a decimal answer probably. Always remember that. Now, if you know how to, do you know how to bounce back and forth between fraction and decimal?
My calculator goes automatically to fraction.
Oh, okay. You have the Inspire, don't you?
Yeah.
Okay. Well, go ahead and come up with this any way you want. But you don't need a calculator. It's 4 times 4 in the numerator and 3 times 5 in the denominator.
Okay, so I got 16 over 15?
Yeah.
Okay.
Yeah. Okay. In other words, I'm still convinced that most of the time people go to the calculator, it's at their detriment. There's very few questions I've come across that really are benefited by a calculator. They intentionally write this test so that they don't want it to be a calculator exam.
Okay. Good to know. All right.
Yeah, it is, because they'll ask you lots of questions that really it can slow you down if you go to the calculator. And there's very few that speed you up by going to the calculator.
I'm so confused on what they're getting in these numbers. So 3 miles in S minutes.
These are confusing. These can be very confusing to me also if they have a combination of multiplication and division in them. And this looks like it probably does. She can run 3 miles, then again, this is a straight ratio.
Yeah.
Let's set up the ratio. The easiest way to solve this is going to be a ratio. So what's my ratio equation?
So it would be 3 S or 3 over S. Yeah?
Mm-hmm. What goes on the other side? There's a missing variable. We need to define our variable.
So
Total. How many miles can she run at 50 minutes? Let's make that X. That's what they're asking for, is X. X is to 50, right?
yeah.
That's the ratio we want to solve. There's 2 variables in it, which means when we solve for X, we're going to have a function of S. So what do we have when we solve for X?
So 150, and then, sorry, I'm doing my math. I don't know why this is so hard. Like, it really shouldn't be, but I'm just doing it.
Well, look at your answers. That might help.
So at 30? That's not even an option. I don't know.
Okay, first of all, don't solve this by cross-multiplying.
Okay.
That's where you're getting messed up.
Yeah.
Solve it by multiplying both sides by 50.
solving, well, you're solving for their equation.
Solving for x.
So then it would be 3 over s divided by 50, so a?
No. Multiply both sides by 50.
Yeah.
Okay, when I multiply the left side by 50, I'm multiplying the numerator. When I multiply the right side by 50, the 50s cancel. That's the reason I multiply by 50, so that I would be left with x. Now what do I have on the left?
You have 150 over 5.
Well, that's where you're getting confused. Now I understand why there was a problem. That's s.
Yeah, sorry, my handwriting. So sorry.
No, that was my problem. I mean, they should never have used s in a problem that has all these 5s in it. Yeah, okay. I couldn't understand why you were having trouble solving that. And then finally I realized it when you said 5.
I'm confused. I was like, where is that?
Yeah, what the heck are you talking about? Who's he talking about? Now, let's go back to that for a second, because I don't want to leave this without mentioning, if you didn't realize it was a ratio problem, there's a surefire method of solving it. Pick a number for s. Make one up. How about 50?
Yeah.
Okay? So s I'm going to let equal to 50. Why can I do that? Because they haven't specified what s is. Whenever you see a variable in the stem and you see that variable in all the answers, you can usually use pick numbers. Okay? In this case, I can pick a really convenient one, 50. So at that pace, how many miles can she run in 50 minutes? 3. So we check each answer using s equal 50, and whichever one comes out to be equal to 3, that's our answer.
Okay.
Unfortunately, that doesn't work nicely because 2 answers come out to be equal to 3, A and E, when you do that. And sometimes, in other words, notice A, when I use s of 50, A is equal to 3 also. But so is E. And since 2 numbers came out to be the right answer, I'm quite certain none of the others are going to be equal to 3. No, they're not. When that happens and you're trying to distinguish between which one's correct, A or E, go back and pick another set of numbers. And that's all it would take. In other words, let's pick 5 instead of 50. Let's pick 25. She can run 3 miles in 25 minutes. We know she'll run 6 miles in 50 minutes. So now plug 25 into there, and whatever equals 6 is the right answer. You get what I'm saying there on how we use picking numbers and back solving in combination?
Kind of. Like, I understand what you're saying, I just don't understand how to apply it.
Okay, well, when I picked 50 minutes, I knew the answer to this question had to be 3, right?
Mm-hmm.
So all I have to do is find out which answer is 3. Well, it turns out 2 of them are. A is equal to 3 when I plug s equal 50 in, and so is E. So to determine which one is actually correct, go back and pick a different number. So I went back and picked 25 instead of 50. Because that's a real easy number to figure out the answer. I know that if she's running in half the time, well, she's going to do twice as many miles. So she'll run 6 miles if she did the first 3 in 25 minutes. So now I have to find out which answer is equal to the number 6 using an S of 25. Notice A no longer works, but E still does. So that means E is the right answer. It worked with 2 different numbers that I tried.
Okay.
It's a little confusing, but it's a really great technique on really hard problems sometimes. for example, I got one here that is really clever. Let me give it to you. It's such a good demonstration of how we should do these. What's that equal to?
Okay. No idea. So.
Very difficult problem. Pick numbers and it becomes so easy you won't believe it. Is all you have to do is, incidentally, the way you do solve this is by grouping. If you group these two together, factor out an x, you get y plus z. Put these two together, factor out a w, you get y plus z. Now we can factor out that binomial, so we get y plus z times x plus w. So this polynomial right here ends up being y plus z times x plus w, so the answer has got to be 30. But very difficult solution, right?
Yeah.
I mean, who knows to do that? Who knows to group them and then factor out a binomial term? We just don't do that very often. However, you're allowed to pick any numbers you want that satisfy this initial condition. So give me an x and a w.
So 2 and 3.
Give me a y and a z.
1 and 5.
Now plug in those values and see what that equals. X times y equals 2. X times z equals 10. W times y equals 3. And w times z equals 15. Those four numbers add to 30. And that was the answer. But you see how easy it was to do when we picked numbers. And we could have picked any numbers we want as long as x plus w added to 5. And y plus z added to 6. When I did it, I picked 3 and 3 for y and z. You don't have to have different numbers at all. You can pick the same, as long as they add to 6. But this demonstrates the absolute enormous power of picking numbers and using that. In other words, when you're taking the ACT test, the goal is not to prove how much math you know. It was nice that I figured out how to group that and factor it, but that wasn't the point. That wasn't really the fastest way to do the problem. The fastest way to do the problem was to pick numbers. That took about 20 seconds to do. Okay? All right, we might have time for one more here. Can you read that okay?
Yeah. So 4,800 pounds. Okay, so just division or multiplication?
Uh-huh.
Yeah?
Yep. It's as straightforward as that. And in fact, you don't really need your calculator. If you look at a lot of these problems and you look at the answers, look at the disparity between the size of the numbers.
Yeah.
Well, what's 6 times 4?
24.
So this thing has to be 24 and change, right?
Yeah.
So it certainly isn't this. It certainly isn't that. That's the only thing it could be, even without a calculator. And there's a lot of problems like that. So it's quite helpful to always look at your answers. I just had a calculus session before you where it was multiple choice and it didn't do any good at all. Multiple choice doesn't help at all in calculus. I covered up the multiple choices and solved the problem and then opened it up and found the answer that fit. But in these kind of problems, multiple choice can frequently make the problem a whole lot easier.
All right.
All right. Let's end it at 42. And I guess I will talk to you next Monday, right?
Yep.
At 5:45. Okay, Sarah, have a good week.
You too. Thank you.
Bye-bye.